Okay, so 5.3, we're going to list all possible rational zeros of this function f of x. To do this, all possible rational zeros, I take the constant a0 divided by the lead coefficient an, and I'm looking at all the possible factors of those. So I'm looking at my lead coefficient and the constant here. So my a0, my an, label those. And so let's see, I've got -3 and I've got 4 here. So what are all the possible factors for -3? That's going to be plus or minus 1 and plus or minus 3. Okay, what about all the possible factors for 4? Plus or minus 1, plus or minus 2, and plus or minus 4. Okay, so I need to do all the combinations that I can. So 1 goes with 1. So I'm going to write it out like this. Got a plus minus, and I've got my little bracket. So 1 over 1. Okay, I've also got 1 that goes with 2. So I've also got 1 over 2. Then I have 1 over 4. 1 over 4. Okay, what else do I have? I've got 3 over 1. 3 over 1. I have 3 over 2. And 3 over 4, right? Doesn't look like any of those repeat, so we're looking good there. If I want to simplify this a little bit, I can. I have all the plus or minuses of 1, 1/2, 1/4, 3, 3 over 2, and 3/4. Not too bad. All right. If you get something, say you were working this out and maybe, you had like I saw that 1 over 1. Maybe I had like a 4 over 4 somewhere in there. Maybe that's not for this problem, but just making it up. 4 over 4 is really just 1. So I would eliminate that one and then just write the 1 that one time. Since it's a set, you only need it in there one time. Don't write 1 more than once. Or if it was, maybe it was like 6 over 2. If that reduced to 3, only put the 3 in one time. Okay, so another type of problem. I want to find all zeros for f of x equals x cubed plus 8x squared plus 11x minus 20. Okay, so what do? I look at the coefficients. Coefficient here is a 1. Coefficient here, or the constant, is a -20. So it's the constant over the lead coefficient, which gets me factors of -20 over 1. So factors of -20, those are going to be plus or minus 1 over 1. Now all of these are over 1, so I really don't have to write the over 1, so I'm just going to knock out that over 1. Also, you're going to have 2, because 2 is a factor for 20. 3 is not a factor, but 4 is. 5 is. 10 is. And 20 is. Okay? If you're having trouble figuring out what factors of 20 there might be, little trick that might help you out. If you've got your calculator, 20 divided by variable x, and then you can look at the table, and you can see here, 1 times 20. Oh, what have I done? All right. Goodness gracious. Come on, buddy. All right. So 1 times 20, 2 times 10, 4 times 5, those are all factors of 20, okay? So 1, 2, 4, 5, 10, and 20. Now, one thing you can do is you can just go through and check with synthetic division for each of these and see if it works. So I'm just going to try this out. All right, so maybe I try -1. In synthetic division, I write out my coefficients. Okay, so first one is 1, and then it's 8, and then 11, and then -20. So I'm going to run through synthetic, see if it's an actual 0. You know, is x equal a -1? Is that a 0? That's the question. If it is, that's really going to help us out. So bring down the 1, multiply, -1 times 1, -1, add the 8 and -1, I get 7, multiply, I get -7, -4, multiplied, and guess what? This is not a 0 since that has a remainder, okay? So you see how to run through this. So I tried -1, let's try 1. So let's just do 1 here. So 1, 8, 11, and -20. Drop the 1 down. I get 1 times 1 is 1. 1 plus 8 is 9. Multiply by 1. Get 20. Multiply. And guess what? That gets me a 0. So that tells me that x equal 1 is a 0. If this is a 0, then if I minus 1 from both sides, I have 0 equals x minus 1. That tells me x minus 1 is a factor. And so then what do I have? Remainder, constant, x squared. So this is x squared plus 9x plus 20, okay, is multiplied by x minus 1. And that's my original f of x, okay? This is good for us. Why is this a good deal? Okay, why is this a good thing? Well, if I have a trinomial, hopefully this will be easy to factor. If it's not easy to factor, then I'll have to use a quadratic formula. And so let's see if we can knock this one out. Okay, let's see if we can knock this one out. So this looks like a is equal to 1, so AC method, multiply to 20, add to 9. 5 times 4, that's 5 plus 4, so that works out. Since a is 1, I just write x plus 5, x plus 4, and then x minus 1 for my other factor. And now this is really easy to find the zeros. I set f of x equal to 0, and so that means x plus 5 equals 0, or x plus 4 equals 0, or x minus 1 equals 0. And so x equals -5, x equals -4, and x equals 1. Uh-oh. All right, let me get back here. So those are the zeros, okay? So when I'm thinking about this function, f of x, which is equal to x plus 5 times x plus 4 times x minus 1. The multiplicity for each of these terms is 1, okay? There's 1 of each of those factors. So that means that I am an odd multiplicity, which tells me that I cross, okay? I cross the graph. So where do I cross at? What are my zeros? My zeros are at -5, -4, and 1. So I cross at -5. I cross at -4. And I cross at 1. Okay? Now, x, and x. Yeah, didn't we already have this already? It was x cubed plus 8x squared plus 11x minus 20. cube is an odd power, so that means opposite. Now the 1 in front is positive, so that means the right-hand behavior is going up to positive infinity. And if it's opposite, then the left-hand behavior is going to negative infinity. So what does our graph look like? Okay, it's coming up from negative infinity, and we're going to cross because it's odd multiplicity of 1. And since it's not greater than 1, we don't flatten out at the root, we just cross through it. And then we come back down and we cross through again at 4 because it's still odd multiplicity, you cross. And then we pop back and cross through again at 1. Okay? So this is what I'll be looking for on the test. Make sure to put the x-intercepts. All right, the zeros. Those are all my zeros. All right. So not too bad. So f does not flatten out for any of the zeros. Okay. All right, cool. If I wanted to find a y-intercept, to get a y-intercept, what do? I set x equal to 0, right? Okay, to get an x-intercept, that's why I set y equal to 0. Okay, y is equal to f of x, right? So if I put x equal to 0, that means I have 0 plus 5, right? I'm plugging a 0 in here, a 0 in here, and a 0 in here. And then 0 plus 4, and then 0 minus 1. So that's 4 times, so that's negative 20. Okay, so this point down here, it's not to scale, but this is 0 comma negative 20. So if you were asked for a y-intercept, you set x equal to 0. Okay, for an x-intercept, I put y equal to 0. Okay, solve for x. All right. Let's see here. What all have we done? We found the zeros. We listed possible zeros here. Okay. All right. So we found those. What if we did this? Okay, let's do an example. Right? Let's do an example. Find the degree, x-intercepts, y-intercepts. Probably just going to be one y-intercept, okay? For f of x equal to x plus 4 squared times x minus 2 cubed times x minus 3, okay? First thing I need to do is find the degree. There's two ways to do it. Either I multiply all this out, or I use this little trick I've got here. Okay, I look at this, the degree of this first term here. All right, looks like it's a degree 2. There's a linear x in here. I multiply it out, I'd have an x squared term. So that's a degree 2. The degree is 2. If I look at this next one here, this is x to the 1, and it's cubed, so that's a degree 3. Okay, now look at this term here, and that's degree 1. So there's x to the 1, so that's just a degree 1 term. Now degree 2, a degree 3, and a degree 1 add up to degree 6. Okay, so if I look at each of those, right, that's like a lead term of x, a lead term of x, and a lead term of x. The coefficient for each of those is 1. So it looks like the first one's like an x squared. The second one's like an x cubed, a 1x cubed. And then the last one's like just an x. Okay, there's only one of them. If I multiplied x squared times x cubed times x together, what would I get? Apparently a sneeze, right? Okay, x to the 6th. That's what I would end up getting. So this is the lead term. This is going to be useful in helping us graph our function. Okay, so we're going to use that information. You might be asked to find the lead term, so I just gave you a little trick on how to find it. All right, so how do I find x-intercepts? In general, I set y equal to 0. Y here is f of x, so set that equal to 0. So if 0 equals x plus 4 squared times x minus 2 cubed times x minus 3 to the 1. Okay? So what? Each of these pieces gets set equal to 0. X plus 4 squared equals 0. X minus 2 cubed equal to 0. And x minus 3 equal to 0. Okay, how do I get rid of the square? I take the square root. I square root both sides, but when I square root, I get a plus or minus. But the plus or minus 0 doesn't really do anything. When you have a negative 0, it's still 0. Okay, so x plus 4 equal to basically 0. All right? Now, technically, there is that plus minus, and so it's x equals, and I'm minus 4 from both sides, negative 4 plus 0, and x equals negative 4 minus 0. But this is negative 4, and this is also negative 4 when I simplify. All right? So this is why we're getting this multiplicity of 2 here. We have 2 x equal negative 4s going on. All right? There's 2 copies going on there. Okay? For this one, when I cube root of 0 is 0, so I get x minus 2 equals 0, so x is equal to 2. And this last one, if I just add 3 to both sides, I get x equal to 3. So my 3 different unique zeros are negative 4, 2, and 3. The multiplicity for this one, there's 2 copies. The multiplicity is 2. Does it flatten out? It flattens out. Why? Because the multiplicity is greater than 1. The multiplicity on the second one here is 3. Why is it 3? The exponent's 3. So the multiplicity is equal to 3. Does it flatten out? Yes. Why does it flatten out? Because the multiplicity is greater than 1. The last one here, x minus 3 equals 1, this has a multiplicity of 1. Okay, multiplicity of 1. No flattening out. Okay, no flattening out because the multiplicity is not greater than 1. So if I was going to graph this, what would this look like for a graph? All right, I have zeros at negative 4. Okay, zeros at negative 4. I have 0 at 2. And I have a 0 at 3. Okay, so I mark those first. All right, those are my x-intercepts. Okay, how do I get a y-intercept? Y-intercept, I set x equal to 0. If x equals 0, okay, if x is going to be 0, that'd be 0 plus 4 squared Okay, right? So 0 plus 4 squared multiplied by, so that's f of 0, right? So multiplied by 0 minus 2 cubed, and then 0 minus 3 to the 1. Okay? When I plug this in, what do I get? I get 4 squared times negative 2 squared, cubed, times negative 3 to the 1. So negative, negative, negative is a negative, times another negative is a positive. So there's 3 negatives and 1 negative make 4 negatives, which makes a positive, right? And then that's a positive. So I get 3 times, oh my goodness, 4 times 4 times negative 2 times negative 2 times negative 2 times negative 3. All those negatives turn into positive. This is 4 times 4 times 4, that's 16 times 48, and then that's what, 96? Oh my goodness, no, that's even bigger, huh? Okay, let's just multiply that out. 4 times 4 is 16, and then 8. 8 and 16 and 3. Okay, so 8 times 16 times 3. Okay, 384. All right, 384. So that's a pretty big number, 384. So that's a pretty big y-intercept. So that's like way up here, 384. It's like even higher than that, but that's okay. All right, what do we know? The lead term when I multiplied all this out was x to the 6. So it's even, so they're either both going up to positive infinity or they're both going down, but the positive one in front tells me I'm going up on the right side. So that's positive infinity. And since it's even, it has to agree. So I know I'm going up to positive infinity on both sides. So how's my graph going to go? So I'm up on positive infinity. I'm coming down. Now at negative 4, the multiplicity is 2, so it flattens out, and 2 is even multiplicity, so it bounces. So I come and I flatten out, and I bounce back up, okay? And I come up through here. I don't care which side you draw the big hump on, just as long as you pass through down here. You don't have to know where the hump is because that's more of a calculus problem, okay, where the hump is. Now, when it comes back down, it's going to come back down through 2, and it actually passes through, it crosses, because the multiplicity is even. If the it's odd. If the multiplicity is even, it actually just touches, okay? So it crosses, but it crosses and flattens out. So when it crosses, it flattens out, and then it comes back, and multiplicity of 1, no flattening out, but multiplicity is odd, so we're going to cross. Okay, so we're going to cross through without flattening out, and it ends up looking like this here. Okay, so that's not exactly what the graph is going to look like, but you get the idea of how that's happening, which is, it's kind of a weird looking curve you got going on here. X to the 6th, and a bunch of subordinate terms. Okay, let's try another one, see if we can make this a little bit more understandable. Say you have a function f of x equals x plus 2 times x minus 3 to the 5th, okay? And you want to find the degree and the x-intercepts, y-intercepts, and graph. Okay. All right. When I look at this, I see the first term. The first term looks like a degree 1. Okay. But the second term looks like it's a degree 5, degree 5. Why? Look, the first one is just an x to the 1 inside, and the second one is an x to the 1 inside, but there's 5 of them. So if I multiplied those all out, I'd end up getting some x to the 5th term, okay? Since there's a 1 in front here. There's a 1 in front here, so I just had the x there. So x times x to the 5th, this is x to the 6th. So find the degree. The degree is degree 6. Okay? So it's even. The coefficient in front is a 1. Okay? These that we work through have coefficients of a 1. If you had something that didn't have a coefficient of a 1, maybe it was like, I don't know, x plus 2 times, maybe instead it was like 2x minus 3. Right, to the 5th. What would be going on here? Well, I'd actually hit, instead of having x to the 5th, it'd be 2x to the 5th, okay? Because there's 5 of them. And then there'd be your 1x going on here. So 2x to the 5th is actually 32x to the 5th. Power to power, multiply everything inside for the exponents. And then your x to the 1. And so that would actually be 32x to the 6 for your lead term. Now that's just to show you what to do in case this number in here isn't a 1 like all of our problems we've been doing. So let's go back to our example. All right, so x-intercepts. I set y equal to 0. So that means 0 equals x plus 2 times x minus 3 to the 5th. So that means x plus 2 equal to 0 and x minus 3 to the 5th equal to 0. So x equals negative 2 is a 0. The multiplicity is equal to 1. Multiplicity is 1. There's only one copy. It's an odd multiplicity, so that tells me I cross. It's less than 2, like it's not greater than 1, so that means the multiplicity tells me that there's no flattening out. Okay, no flattening out. Now for the second one, I'd take the 5th root, both sides. 5th root of 0 is still 0. So x minus 3. That means x is equal to 3. That's the 0. My multiplicity here is equal to, well, how many are there? There's 5 of them, so there's 5 copies. 5 copies. So if there's 5 copies, then that's odd multiplicity. I cross. Now the multiplicity is greater than 1, so that tells me I do flatten out. And I flatten out significantly. The higher the multiplicity, the more you're flattening out. Okay? So when I try to graph this, what's it going to look like? Well, if I cross at negative 2 and 3, I know I'm going to cross maybe at a negative 2. And I'm going to cross at 3. Okay? What did we say? The degree was 6. All right, so what? So was this, let's see, yeah, it was x cubed, or x to the 6. So it's even, so they both agree, and it's a positive in front, so that means they both agree and they're both going to positive infinity. Okay, so my graph, the curve, when it comes down from positive infinity, it's coming down. And how do we cross at negative 2? We cross with no flattening out, so we go straight through it. So that's what I'm looking for, to go straight through it. Okay? And then I come back up, and whenever I come back up, when I cross through at the root of 3, the multiplicity is 5. So I'm going to cross, but I flatten out when I cross. So when I flatten out, there's a little bit of a bend here. That's the flattening out. So that's what I'm looking for, that little bend. So that's what you're going to draw on your scratch paper, right? And then it's going to shoot up to positive infinity. Now to get that y-intercept down here, to get the y-intercept, I set x equal to 0. So if I set x equal to 0, I get 0 plus 2 times 0 minus 3 to the fifth. So that's 2 times -3 times -3 times -3 times -3 times -3. Type that in your calculator or just put to the -5th power. So 2 times -3 to the 5th. What is that? 2 times parentheses -3 close parentheses to the 5th. -486. -486. Okay, so I'm crossing down here at 0, -486. All right, so that's my graph of f of x. So the big difference here, when I look at these roots, with this one here, there's no flattening out. With this one, as I come in, I flatten out at the 0 and then I take off. Okay, so the closer I get to the 0, the more flattened out the curve becomes. All right, guys, we can do one more to make sure that we've got our understanding going on, okay? So here I just want to use long division to help me find the zeros. So we'll finish this 5.3 out. Can't stress how important that this section is for the remainder sections. Okay, so find all zeros. F of x equals x cubed plus 7x squared plus 11x minus 3. Okay, so when I see this problem, the work I want to see is possible rational roots. Possible rational roots. So I need to know the coefficients of the lead coefficient and the constant. So the constant on top and the lead coefficient on bottom, I get the -3 on top and the 1 on bottom. I do plus minus. What are the factors for -3? It's 1 and 3. Okay? So I've got 4 numbers I can check. Now, I want to give you a way to help you work through these problems quicker. Because you can do the synthetic with 1, -1, 3, and -3. But what you're going to find is it's going to fall apart for you for those first 3, but then it ends up working for the last one. So it is possible to run through it, but I want to give you a shortcut on what I would do if I were you. To show your work, all right, you can throw this into your calculator, all right? So x cubed, okay, x cubed plus 7x squared plus 11x minus 3. Boom. Okay? So now what we're going to do, we're going to go to the graph and we see, okay, looks like there are some roots going on. So let's do second calc and see if we can find any of these zeros. So I want to go left bound. So let's go to the left side, okay, over here. And then I'm going to go to the right side. I can't go too far. If I go too far, I won't get the one I'm trying to do. So this looks like a nasty one. X equal -3.21. Yikes, right? So we may want to write that down, but that's not going to be good enough for us, right? So -3.21 maybe? I can't even remember. Okay. And then let's try this again. Second calc, and let's find the 0. And so I want to go left bound, so I'm going to go left bound, and then I'm going to go on the right bound. And so this one gets me an x. Wait, what is going on here? Hold up. I think I might have messed up here. Okay, let me go back. Second calc, 0. So I want to go on the left side, then the right side. Okay, negative 4.236 is the 0 here. Negative 4.236. This is just a little weird. Negative 4.23. Something like that. 6 or something, I don't know. Okay. So let's get back in. So second calc 0. So left bound, right bound. So 3.00004. So negative 3.0004. I think that that's going to be 1. It's basically negative 3. Okay? So that one's telling us negative 3 is our answer. So that's how we're going to use it to cheat for us, if you will. All right, a left bound here, go over here, and then over here, and I get like 0.236. Okay, so x equal to roughly 0.236. All right, so these are going to be no good for us to use synthetic on, but this one is really close to negative 3, so we've got a good chance of this one working for us. So let's just try it. So negative 3, put in our box. Now 1, 7, 11, and negative 3 for the coefficients. Draw a line, drop it down. Negative 3 and 1 makes negative 3. Add those, you get 4, and then multiply, you get negative 12. Add them, you get negative 1. Multiply negative makes a positive 3, and this gets you 0. So what's that tell me? X equals negative 3 is a 0. Okay, by our little remainder theorem, right? This is the remainder, this is the constant, this is the x, and that's the x squared. So I have x squared plus 4x minus 1 multiplied by, well, if I add 3 to both of those, I get x plus 3 factor equal to 0. So multiply by x plus 3. So this is a way to reverse engineer to get your solution. All right, pretty good trick. Okay, so that's my f of x. Now I'm down to a quadratic and a linear term. Okay, so to solve the quadratic, you can try to factor, but guess what? This one's not going to factor. You're going to have to use the big guns here, quadratic formula. So the quadratic formula is negative x is equal to negative b plus or minus square root b squared minus 4ac over 2a. Now a x squared plus bx plus c, that's all equal to 0. So if I'm setting that equal to 0, this piece right here, my a is equal to 1, my b is equal to 4, and my c is negative 1. So I'm going to plug it in. Negative b, so negative parentheses 4, plus or minus square root 4 squared minus 4 times a times c over 2 times a. So what does that get me? It gets me negative 4 plus or minus square root. Now this here, that's 16 minus, and a minus gets me a plus 4 over 2. So this is negative 4 plus or minus. Now square root of 20. Square root of 20 actually simplifies. That's 4 times 5. So that gets me, and then 2 and 2. So 2 can come out of the house, but the 5 stays in the house. So that's 2 square root 5 over 2. All those have a 2 in common, so this reduces to negative 2 plus or minus square root of 5. All right, negative 2 plus or minus square root of 5. So what are my roots? What are my zeros? So find all the zeros. The zeros are x equals negative 3, negative 2 plus the square root of 5, and negative 2 minus the square root of 5. Now, if you type in negative 2 plus the square root of 5, let's see what we get. Negative 2 plus the square root of 5. That 2.36, that looks familiar. And then the negative 2 minus the square root of 5, that negative 4.236, those both look familiar. Where are those coming up? They're coming up right here. Okay? So giving me the decimal answer, while it's good to check, is not the same as giving me the exact solution that I have here. And this is how I know whether or not you can do it, is if you give me that exact solution right there. So that's what I'm looking for. All right, guys, that concludes our video.